Thank you, Dennis. Thank you for the introduction, and thank you for the invitation to come here today. I will talk about the nutritional value of animal proteins fed to pigs, and it is a topic we have not talked so much about over the last few years. It used to be that pigs could not be raised, maybe you remember this, Dennis, pigs could not be raised without any animal proteins, right? And because there was this thing they called the animal factor in animal proteins. Every time they took the animal proteins out, the pigs didn't do very well. Well, then at some point it was discovered that the animal factor actually was vitamin B12, and when vitamin B12 was discovered and they could start synthesizing that and producing it synthetically, it became possible to produce pigs without animal proteins. So we don't have a requirement for animal proteins anymore. However, we do have quite a few animal proteins that are available to us. And we have had the opportunity over the last few years to work with quite a few of those proteins. So what I'll do is I'll show you some highlights for that, but you do have in the proceedings, you have kind of an overview over everything we have done. There's 8 tables in there, and I'm not going to go through all those numbers, but if you want to have references for composition and for digestibility in those particular ingredients, you have it all in the proceedings. So I'm not going to go through all the numbers. I'll just show some highlights here. So what I'll try to do and what I'll try to tell you is, number one, when you work with animal proteins, ash all of a sudden becomes an important nutrient. Okay, I have sometimes when we submit papers for publication, we always include ash if we have ingredients there when we analyze them, because it's easy and cheap to analyze it. But reviewers sometimes say, why are you giving us ash values? That has no interest to the reader of this publication. Well, I disagree with that, because it is of interest to know the ash value, and actually the ash value can tell you a lot about an ingredient, and in particular about animal protein. So I'm going to talk a little bit today about ash and how we should value that. Okay, I'll also talk a little bit about fish meal, because the one animal protein we have used constantly over many years is fish meal. However, prices have gone up dramatically over the last few years, and we look for alternatives. And as prices of fish meal have gone up, this is my opinion, quality of fish meal has gone down, and I'll show you why. Okay, so I'll talk a little bit about that also. I also will talk a little bit about some byproducts or co-products we have from the poultry industry that are available to us, and there's basically 2 different groups. There's one group of poultry co-products that we can use in diets for weaning pigs as substitute for fish meal, and then we have another group of co-products, the feather meals, that we can use for growing finishing pigs. So I'll show a few values on those products also. And then I will come back at some point and talk about a little bit about heat damage, because when we talk about animal proteins, we always talk about proteins that have been somehow processed and heated. And every time you heat a protein, you run the risk of heat damaging that protein. So I will talk a little bit about that also, and have a few comments on that. So those are the things I'll cover here, and those are the things I hope that you will remember once I'm done with my talk. Okay. Before I go on, I do want to acknowledge my co-author on the paper, and I shouldn't say he's my co-author. I'm actually the co-author. He wrote most of the paper. This is one of my PhD students, Oscar Rojas, and he wrote the paper. He has done a lot of the work that I'm going to show here today, and he also prepared some of my slides. So he has a big hand in the thing here today. And as you all know, good students, they do make professors look smart. So if you think I look smart today, it's all because of Oscar. So please acknowledge him for that. Okay. When I start, my favorite slide here is the 6 classes of nutrients. As I said before, we have the 6 classes of nutrients here: water, protein, carbohydrates, lipids, vitamins, minerals. And energy is not a nutrient, as you all know, because animals and humans get energy from oxidizing protein, carbohydrates, and lipids. Okay, nothing new here. But what you will notice here is that the highlights here is only protein, carbohydrates, and lipids, and not the minerals, not the ash. That means there's no energy coming from ash. And it comes back to here talking about ash when we talk about animal proteins. Okay, so there's no energy when we talk about ash. Show you results of a study we had published earlier this year. This is whey permeate. We had 2 different types of whey permeate. One of them contained 8.96% ash. The other one, 1.72% ash, so this was a de-ashed whey permeate. And as you would expect, energy value is much greater if you take the ash out here than if you don't have, if you have ash in this permeate. So again, there's no energy in ash, so every time you have ash in an ingredient, you have the risk of lowering the energy in that ingredient. Okay? Some of the animal proteins we have, they are produced from what they call whole carcasses of animals. Okay, and that's actually a little bit interesting to look at. You can get poultry meal that's whole spent hens, or you can get fish meal claimed to be from whole fish. Now, if you think about that, you should be able to pretty accurately calculate what should be the gross composition of that product if it is, in fact, whole animals. Because most grown animals, they have a pretty similar and pretty common gross composition. I'm just showing here a steer, a pig, and a laying hen, and you can see most of what we have in the body here is water, and we have some protein, we have some lipids, and we have 4 to 5% minerals or ash, right? So that is the composition you have. So that's what you should expect when you, if you have whole animals. Now, this is kind of my average here for the whole body. We don't buy proteins that have this composition because obviously the water is taken out of it, and a lot of the fat is taken out also. So what we buy is kind of a dehydrated, defatted product coming from this whole carcass. And if my calculations are right, if we again have a whole animal, composition should be something like this. Water is typically taken down to 8-10%, so we have dry matters of 90 to 92%. Fat is taken down to somewhere between 10 and 14% usually, so they have taken some fat out, but so the products we buy typically contain 10 to 14% fat, but then the ash will be there and the protein will be there. So a product that contains about 65% protein, 15% ash, and then some water and fat, that would be typical for a whole animal that has been processed and made into a meal. They're taking some fat out, taking some water out, and the rest is there. Okay? So every time you buy a product, when they claim it is a whole animal, then if the composition is something like this, you say, yes, I believe you. However, sometimes we see these whole animals and ash is 20-24%. Okay? Then it's not a whole animal anymore. Then it's probably a whole animal plus a lot of bones from a particular industry, because in the human industry there's a lot of leftover bones, whether it's fish bones or chicken bones or whatever it is. So they kind of stretch their product a little bit by adding value to those bones and selling it as whole animal bones. And you can tell that by looking at the ash concentrations more than anything else. If you are much above 15%, you know it's not a whole animal anymore. Okay? Obviously, we have used meat and bone meal, and that may be the product after fish meal that is most known. Few numbers of this. This is from a publication we hope to get published next year. We have it in review right now. And crude protein on average, this is from 8 sources of meat and bone meal from commercial producers here in the United States. We obtained fat about 13%, crude protein 52%, and ash 27%. Obviously, this is not whole animals. These are, and nobody is claiming that these are whole animals. This is offal from the slaughter industry, right? And you can see there's quite a bit of variation here in the ash content, a little bit more than in the others. But if we look at calcium and phosphorus, we have a lot more variation, right? And this is a little bit of a concern, because if you formulate a diet and if you use meat and bone meal for these pigs, a lot of the calcium and phosphorus will come from meat and bone meal. And if you believe the average is 4.2%, so that's what you formulate on, and you get this quality here with only 2.6%, then those pigs will not get enough phosphorus. Okay? So this is something that you have to be a little bit concerned about and have to try to predict what is the phosphorus and the calcium concentration in a specific source of meat and bone meal. Now, the good news is, actually, if you determine the ash in this meat and bone meal, then you can predict both calcium and phosphorus pretty accurately just by determining ash, right? So what I'm saying is, ash is easy to determine, it's cheap to determine, and just by doing that one analysis, you can actually get a pretty accurate estimate for calcium and phosphorus in this product. Okay? So again, ash is an important nutrient. Okay? You can also, if you do a little bit more, look at the digestibility. If you want the digestibility of phosphorus in this meat and bone meal, we have here standardized total tract digestibility of phosphorus. And there's an equation here. You can see you need to know ash and you need to know calcium. Okay? So if you have calcium and ash, you can actually relatively accurately predict the digestibility of phosphorus in this, this ingredient. Okay? And if you want to have the digestibility of calcium, again, you need ash concentration and calcium, and you can use this equation and you'll get the digestibility of calcium. Okay? So depending on how accurate you want to be in your formulation, definitely analyze for ash if you have this meat and bone meal, and maybe also for calcium, and that will tell you a lot about the value of that particular product. Okay? And as I said, I hope we get this published in Journal of Science early next year. Coming back to fish meal, I said the quality seems to have gone down a little bit. These are sources, I believe there are 9 different sources of fish meal that we have procured at the University of Illinois over the last 3 to 4 years. We have used them in different experiments, and we have just happened to analyze them. And if you can see there's a little bit of an increase in ash. In the last batch we got here was actually 24% ash. So it's almost meat and bone meal. Right? Remember, the average meat and bone meal was 27% ash. So this fish meal, which is sold as being whole menhaden fish meal, is clearly there's quite a bit of fish bones in there from the fish industry. Okay, so we have also in a few of these experiments we have determined D and ME values, and I believe there are 5. We have 5 experiments here. We had that, and you see the new swine NRC. They claim there's 3,606 kcal per kilogram in fish meal. The average of our 5 experiments is only 3,472. So again, because ash is going up a little bit, it seems that energy is going down. So we may not get quite as much energy out of that fish meal as we think, right? However, amino acids in fish meal seem to be well digested. We are still over 80%, and there doesn't seem too much change in amino acid digestibility. However, we have seen crude protein concentration go down. Also, we have some sources where we're down to 61% crude protein instead of 62 to 64 as we used to be. So the concentration of protein may go down, but digestibility seems to be pretty standard for this fish meal. Okay. Whey powder and whey permeate, just a few slides here. These are not real protein sources, but I did want to take them also because we do use milk proteins and milk products in our feeding. And we start to look at what they do to milk. In the dairy industry, we have whole milk. They typically take the casein out and maybe the fat out also. Then they have the whey left over here. This goes into the cheese. Whey is left over. Then if you take the proteins out of the whey and produce whey protein concentrate, then you have whey permeate left. Okay, and this is a pretty standard practice, and it's becoming more and more common because whey protein concentrates are very, very expensive in the human food industry because it's used to stabilize protein when they make sausages and many other things. So they use whey protein concentrate for that. So a lot of the whey proteins go into the human food industry, and then we are left with whey permeate, where whey has about close to 70% lactose. Whey permeate may have between 80 and 85% lactose. It's still a very good product, but as you saw before, it contains quite a bit of ash. But sometimes they take the ash. If they take all the ash out, we get pure lactose out of it. But they sometimes take some of the ash out, and then we get a low ash permeate, as I showed you before. So these are kind of where these products are coming from. We have D and ME in whey powder and in normal permeate, which is called Perlac, one source of permeate called Perlac, and then we have the low ash, which is called Variolac 960 here. And you can see that the energy in whey powder is greater than in Perlac because you have the protein here. When they take the protein out, energy goes down, but then when they take the ash out of the permeate here, then we get energy back up to something that is actually a little bit better than in whey powder. Okay, so when you buy these permeates or whey powders, there are differences among sources, but again, if you look at ash, if you look at crude protein, it'll tell you a lot about what kind of a product you have there, and in particular about the energy value. Also, when you use milk proteins and most other animal proteins, you have products with high digestibility of phosphorus. Obviously, we don't have the phytate problem in animal proteins, so whatever phosphorus is there is usually very well digested, and you can see here you have standardized digestibility coefficients above 90% for all three of these products here. Right? So, milk proteins, again, look at ash, look at crude protein, and predict energy from that. Okay? Then we have the poultry industry. We have some products, byproducts from the poultry industry. And as we get into some of these products, we get into products that are very company specific. And this may create a little bit more of a challenge because some of these products are produced just by one single company and then marketed, okay? Where meat and bone meal, fish meal seems to be standard among the industry, whey permate, same thing, whey powder. But when we get into some of these more specialized products, maybe there's only one company producing them. So that makes it a little bit more challenging. We have something called chicken meal, and we also have poultry byproduct meal. Both of these products are sold as fish meal alternatives. They are used in diets for weanling pigs, and they can often be included, and pigs will do very well on these products. Chicken meal is a product that is claimed to be from whole carcasses of poultry, and there can be bones in there, and sometimes there are no bones. It says without or with bones. Okay? And poultry byproduct meal is the offal of carcasses of slaughtered poultry. That's the definition, and it does include feet, necks, undeveloped eggs, and intestines. Okay, that's the definition from AFCO for these two products. If we look at crude protein, ash, fat, and energy, you'll see for chicken meal, 66% crude protein, 14% ash, 11% fat, and energy here 36.94. A little bit better than in fish meal, a little bit better than in corn. Looks pretty good. And if you remember back to one of the first slides I showed with the expected composition of an animal meal, if it was from a whole animal, this is actually pretty close. So when they say whole carcasses of poultry, it looks like that is very close to what you would expect there. Okay? Poultry byproduct meal contains many more different things, and it does contain offal from the slaughter industry, but ash is not very high here, so it's not overloaded with bone. Fat is a little bit higher, and therefore we have more energy, although the protein is a little bit less. So it looks like it's a pretty good product, and as I said before, you can include both of these products into weaning pig diets, and the pigs, they'll do pretty well, okay, at least for these particular sources. We have another product called AVE Digest, and it's produced by a company in Des Moines, Iowa, and they are mixing. They're taking whole spent hens, enzymatically hydrolyzing them, and then mixing with extruded egg albumin and soybean meal. And the soybean meal is in there, they say, to absorb some of the fats and produce increased handling characteristics, so it flows better. The product contains 49.5% crude protein, 14% ash, 15% fat, and 3,235 megacalories of energy. We have not done any studies where we have looked at the value in a feeding study with pigs, so we don't have any experiences with that. But it looks like a reasonably good product. Obviously, the crude protein here is lower than in poultry byproduct meal, probably because of the soybean meal. But the digestibility of these amino acids are actually a little bit greater than in poultry byproduct meal, because soybean meal has a greater digestibility than poultry byproduct meal. And since this is a combined product, we have seen that the digestibility is kind of in between poultry byproduct meal and soybean meal. So it seems to be a reasonably good product, but we don't have much experience using it. Okay. You can also get feather meals from poultry, and obviously there's a lot of feathers produced in the United States, and those feather meals are typically steam hydrolyzed before they are used, so they are cleaned and then steam hydrolyzed, and then sometimes the companies producing them, they take the blood from the poultry and add to it and dry it, and sometimes they don't. So they may be without added blood or with added blood. There's a lot of protein, 82% protein in feather meals. However, it is relatively low quality protein, and then the lysine concentration is low, but we have relatively high concentration of threonine, isoleucine, and valine. Okay? So in some of our diets, when we don't have too much soybean meal, sometimes we get into low concentrations, in particular of the branched-chain amino acids and threonine. So maybe it could have a place there. There has not been a lot of studies on feather meal usage in growing finishing pig diets, and some of the ones have indicated only up to 8 to 10% can be included without reducing performance. But I wonder if you get them all well balanced in all amino acids and formulate on digestibility values for all amino acids, maybe you can include more. I don't know. We are in the middle of conducting some research on that right now. So we hope at some point we can get more information on hydrolyzed feather meal. There's 80% crude protein, as I said. Ash is very low because it's feathers here. There's not a lot of ash here. Fat, 7 and 9% in these two products here. And energy relatively high because of the low ash concentration and the high protein concentration. So there's a lot of energy in feather meal. And pigs seem to be able to utilize it pretty well. Okay. We also have another group of proteins called intestinal byproducts. And here we have, this is again a company-specific product, Porsol or DPS50, the same product, and it consists of enzymatically hydrolyzed intestines. Okay, so the intestines from pigs are simply collected at slaughter plants. They extract some heparin, and then they hydrolyze the rest of it and make it into this product. There's also another product from another company called Pep2 Plus, and here they use porcine mucosa from intestines, and then they mix them with something called dried fermentation biomass. And dried fermentation biomass is coming from the synthetic lysine production industry, and they also mix it with HB300, which is an antigen-free soybean meal that is produced also. So they mix these products together and sell it. They have the same company has another product called Pep50, and again they use porcine mucosa here, but they only use soybean meal to mix it with, not the fermentation biomass, and no HB300 here. So they mix these products together and sell them again as fish meal alternatives in weaning pig diets. The Porsol, the first one here, I found a summary that my colleague Dr. Pettigrew did a few years ago, and he looked at different animal proteins, say what happens when, what has been published on using different animal proteins, plasma, whey, egg proteins, and Porsol, and you'll see improvement in average daily gain for plasma very high, not a surprise. Eggs and whey, not quite as much improvement, but then if you add Porsol on the at that time published experiments, it actually looked very, very good when you added Porsol to diets to weaning pigs from studies that have been published. So from that perspective, it looks good. Energy, we have in these two, Pep2 Plus and Pep50, we have determined that very high energy values. So also from that perspective, it looks good. And you have data for all the other nutrients in the proceedings. We have a paper on this that is in press in Journal of Animal Science right now. So to conclude on these intestinal byproducts, they appear to be valuable ingredients, sorry for the typo here, in diets for weaning pigs, and they may probably substitute fish meal and possibly some of the blood products in early weaned pig diets. They don't smell good. If you get them, they smell like intestines, I'll tell you that, and sometimes more like intestinal contents than intestinals. But we have not seen negative effects on feed intake, so it looks like the pigs, they like them. And in the studies that have been published also, you don't see a reduction in feed intake when you use these products. So apparently the pigs, they don't mind too much. So that's a conclusion on these intestinal byproducts. Again, they are company-specific products, and you'll have to work with the companies. There is actually another company in Iowa. They are starting to produce a bovine intestinal product, but I don't have any data on that, and I don't know what the characteristics are, but that's coming out also apparently pretty soon. Okay, a few words about heat damage and proteins. And I'll step away here for a second from animal proteins because we have worked quite a bit on heat damage in our group, but we have not done any specific work with animal proteins. But just to show the principles, I'll come back to animal proteins in a second here, just to show the principle, show what happens if you heat. This is autoclaved soybean meal. You have a controlled soybean meal, autoclave for 15 minutes, autoclave for 30 minutes. Then we have an oven dried, and you can clearly see the change in color here for the autoclave, not for the oven dried. And that tells you you can damage or you can change soybean meal by autoclaving it, but it doesn't. You don't seem to get the same effect for all drying procedures. So drying procedure is important in determining how you handle proteins. L star values go down as you autoclave, A star values go up, so it becomes browner, and obviously you can see it becomes browner here. So we published this last year in a publication, looked at amino acid digestibility and the control, and the two autoclaves. See, there's a linear reduction in lysine digestibility here, and actually also in most of the other amino acids. Okay. We looked at crude protein in these sources. There's no difference in crude protein, so you cannot detect heat damage by looking at crude protein concentrations. However, if you look at lysine, you'll see a reduction as we heat damage these autoclave sources here, but again, no difference to the oven-dried here. There was no difference in digestibility, no difference in color, and no difference in lysine concentration. So lysine concentration tells you something. If you divide lysine by crude protein, you also see a clear reduction as we heat damage the proteins. As we heat damage proteins, we see reduction in lysine concentration and in lysine digestibility. They always go together, those two things. And you can use this lysine to crude protein ratio specific for every protein to estimate heat damage. Okay? So with that, if we go back to the animal proteins, I've just listed all the animal proteins I've talked about here: the chicken meal, poultry byproduct meal, AV digest, the peptone 2+ and peptone 50, the DPS or porsol here, meat and bone meal, and 2 feather meals here. And you will see lysine digestibility. You see clear trend here. We have some very low digestible lysine here. You have some very low digestible lysine over here, and then you have some very high digestible lysines in the middle, right? Some of these may be because of the character of the protein. You could say maybe the feather meal is just difficult to digest it, so maybe that is the reason. You can't say they are heat damaged maybe from this, but some of them you can. And one thing that we always look at when we do these digestibility trials with amino acids, look at how do the amino acids fit together, because as I said before, heat damage reduces lysine concentration and reduces lysine digestibility. If you look at this is a chicken meal here. We had chicken meal, one of the low ones here. Look at those. Lysine digestibility around 60, but the other amino acids higher than that. And if you see something like that, then you would say, yes, it's probably heat damage, because how can lysine digestibility be even less than threonine? They should be kind of in line, all of them. And if you see something like this, there's a very, very high likelihood this protein was heat damaged. Okay, so you can look at it that you can look at lysine concentration, you can look at lysine to crude protein ratio, and you can try and look at lysine digestibility compared with some of the other amino acids. This is one of the feather meals. Again, lysine much less digestible than the other amino acids. Clearly, we have heat damage here, and that is always a risk when you heat a feed protein, that you damage it because you overheat it, and that's clearly what is happening here. So look at some of these things, and you can determine heat damage in several different ways, but if you have data for digestibility, if they show you this, then they're pretty much telling you that they are heat damaging the protein. Okay? Last thing I have here, Dennis, before I finish up, is a few words on blood products. We do use blood products in animal proteins also. We have here a number of different blood products we have worked with: avian blood, porcine blood, bovine blood. We have plasma protein. As you all know, we have blood cells, and then we have something we just call blood meal here. That is a mixed blood meal, but it's spray dried, where these ones over here are ring dried or drum dried. These 3 products are all spray dried. Okay, and crude protein, obviously, in all blood products is very high. The lowest one is plasma protein. Other than that, we are above 80% in all of these blood products. If you look at digestibility of lysine, you can see some clear differences again. The avian, the porcine are less than the spray-dried blood products over here. And again, this is because of the drying procedures. When you ring dry and drum dry, you do damage some of the amino acids in those blood products. If you spray dry, you don't damage them, so they are very digestible if you have spray-dried products, whether it's blood meal, blood cells, or plasma protein, all very digestible if they are spray-dried. So clearly a processing effect on digestibility of amino acids here. Digestibility of phosphorus in blood meal, we did a little bit of work here a few years ago, and it's like other animal proteins. Phosphorus in blood meal and blood products are very, very digestible, more than 80% here. In spray-dried plasma protein, pretty much 100% digestible. Phosphorus is very digestible in these sources, and plasma actually contains quite a bit of phosphorus, so it's a good source of phosphorus. So with that, I want to finish, Dennis, and I want to acknowledge not only Oscar but also all the other students I have in my group. They all have helped with these studies, or many of them have. This is our current team there, and if you are interested in knowing more, then we do have a website, and there's also a free newsletter on the website you can sign up for, and we do send out newsletters every month on updates on what we are working on, so you're welcome to visit our website and follow our work. So with that, thank you for your attention.